Hello! Yes, and welcome to our Objective 1.3 notes. Now, Objective 1.3 states, I can describe the graph of a function by stating the end behavior and the intervals of increasing, decreasing, and constant. So, whereas last section, 1.2, last objective, we were looking at maybe how the equation and the graph related. This time we're just really looking at the graph itself. So let's get started by talking about end behavior. End behavior recognizes the direction the graph is going as x, our input, approaches positive and negative infinity. And what that means is as I'm going to the left, what is my graph doing? And as I'm going to the right, what is my graph doing? Here are the four possibilities. We use the term rises and falls. So this first one here, this is an example of a graph falling to the left and rising to the right. Falls to the left, rises to the right. And that's because as I'm going left, my graph is going down. Whereas as I'm going right, my graph is going up. Falls to the left, rises to the right. This next example over here is falls to the left, falls to the right. As I go to the left, my graph is going down. As I go to the right, my graph is going down. Falls to the left, falls to the right. This bottom one here is an example of rises to the left and rises to the right. Now you're probably thinking, hold on, Mr. Carter. I can see it drop here. It's going down. Right, you are absolutely correct. However, the only thing we care about is the final direction it goes. So in the middle, a graph can do anything. We just care about how it's ending. All right, so this one is rising as it goes to the left, and this one is rising as it goes to the right, even though they both fall in the middle. We don't care about that. Just as, remember, this is as x approaches negative infinity and positive infinity. And then the final option, rises to the left, falls to the right. So here we go, going up to the left, going down to the right. Again, in the middle, it doesn't matter. What we care about is as x, or as our input, approaches positive and negative infinity. So these are the four possibilities. Every graph will be able to fall into these four ideas. So that's end behavior. The other idea we're going to discuss is increasing, decreasing, and constant intervals. All right, so increasing interval, as demonstrated here, is as x increases, y increases. So this means as I move from left to right, because that's when x is increasing, what is y doing? So we can see here from this example, as I move from 2 to 4, the y value is going up. Decreasing then is as x increases, all right? We're always moving from left to right. So as x increases, y decreases. So an example here, as we go down, we're going down from -2 to 0 here. That graph goes down. It is decreasing from -2 to 0. Constant is as x increases, y doesn't change. And here's an example of that constant from 0 to 2. There is no change in y. All right, when writing our increasing, decreasing, constant intervals, we use interval notation, since they are intervals. And note that we always are going to use soft brackets. All right? Even if we have closed circles here, we're going to use soft brackets because at that point, it's neither increasing, decreasing, nor constant, right? So we'll always use soft bracket. Now notice how I've been describing these. I've been describing these by using, oh, hello. I don't know how that happened. By using our x values, okay? So our x values, like -2 to 0, would be the decreasing range. Even the y value changes from 4 to 1, that's not what we're going to notate. We use the x values for increasing, decreasing, and constant. We're not wanting to see how much it increases or decreases. We're wanting to see where it increases or decreases. So let's try a couple together. Let's look at letter A here. So identifier in behavior, state where it's increasing, decreasing, or constant. So first thing, in behavior, I can see very clearly that as I go to the left, this graph is going down. As I go to the right, this graph is going up. So this then falls to the left. Oh, man, writing on this is hard. Rises to the right. I'm going to have to write a little smaller. Okay, falls to the left, rises to the right. That would be the in behavior here for letter A. Now, where is this increasing? Well, this is increasing from, let's see here, negative infinity all the way to -2. Soft brackets on everything, remember, and union, which means it's multiple intervals where it's increasing because it's also increasing from 4 to infinity. Now, how can I fit that? There we go. We'll call that good. All right. So this is increasing from negative infinity to -2. Again, we're looking at our x values. So negative infinity to -2. It stops increasing at -2. And then again, it starts increasing from 4 to infinity. Now it's decreasing from -2 to 4. Over those x values, the y value is going down. And then it's not constant anywhere, so we can say like not applicable or none, something like that. And there's letter A. Let's try letter B. So in behavior here, as I go to the left, definitely rising. If I go to the right, it's also rising. So this would be rises to the left, rises to the right. Rises to the left, rises to the right. Awesome. Increasing. So increasing, decreasing, constant, remember, is left to right. So as I move left to right, we're going down, then we're constant. We are increasing, however, from 2 all the way over. So we're increasing from 2 to infinity. There we go. We are decreasing, like we said, all the way from negative infinity down to here, which is -5. Remember, we're looking at our x values. So we're decreasing from negative infinity to -5, and then we are constant from -5 to 2. And there we have it. All right, that is increasing, decreasing, constant, and in behavior. Let me know if you have any questions. If you're feeling confident, go ahead and look at those practice problems. If you want a little more practice before you do it on your own, go ahead and check out that sample problem video, and then we'll hopefully build up our confidence a little bit more. All right, well, this is Mr. Carter signing off. I'll see you next time.